Welcome to EDU World Space.
So a sequence AN is defined recursively by this formula up here, assuming that n is larger than 3 or more. A1 and A2 are any numbers that we choose. Now let's experiment with some values of A1 and A2 that we get to choose, and then we'll guess the limit. So for part A, let's come over here and choose some values for A0 and A1. This is our A0 up here, f of 0, and this is our A1, f of 1. So let's do A0 equals 0, A1 equals 10, and then our guess for the limit. Here, we can draw, like say if we look at the 10th term in the sequence, it's given down here by about 0.66. And you could kind of see that the numbers are getting, it looks like they're ganging up at around 0.66. So that would be a guess here, 6 2/3. Now let's maybe try different values of A1 and A2. So here let's try, for example, -10 and then +10. And then here, maybe we'll need more terms to see what's going on here. Let's try maybe 30 terms. And it looks like this is going to about 3 1/3. So here I should have done A1 and A2 originally. Sorry about that. Then down here, if A1 is -10, A2 equals 10, then I can see that the limit is about 3 1/3. So now let's go ahead to part B, onto the next page. So for part B, let's record some values of n, an, and then also the an plus 1 minus an. Or excuse me, I should do an minus 1. So for example, if n is 1, a1, nothing yet to subtract. 2, then a2. We can't use the recursion yet. Remember, the formula starts for n bigger than or equals to 3. That's why here I'm not using the formula yet. And then over here, I have a2 minus a1. Now I start using the formula. So instead of a3, I write a1 plus a2. These are both over 2. And now I have a3 minus a2. So in this case, I have a1 over 2 minus a2 over 2 after I replace a3 with this, and then subtract off a2. Do one more value here. Now I have a4, but a4, I could go ahead and use the formula. So a4 is a3 plus a2 over 2, and then I know a3 from over here. So after simplifying all of that and writing it in terms of a1 and a2, and then similarly, so this, let's see here. Be careful with a1 minus a1 over 4 plus a2 over 4. Sorry about that. And we could keep going in this pattern. But from this, all we're going to conclude is that we can rewrite the limit of an as n goes to infinity. Well, now we just look at the rightmost column. And you can see that if we just add up these terms, we'll end up with an, because here we'll have the cancellation, basically a telescoping sum. So if we take the limit of this, and after we do the telescoping, we'll end up canceling the a1. Well, the a1 will, that part we'll actually have to make up for that by just writing a1 here, because we see that doesn't cancel. And then we'll have negative a1 plus a2, so the a1s will cancel. And then we would do negative a2 plus a3. The a2s would cancel, and you could see if we keep going in this pattern, everything cancels out except the an. So here would cancel the a1s, a2s, a3s, and so on, and you're left over with an. Now we'll use the fact that in the parentheses, we've simplified all these expressions in terms of a1 and a2 only. So going on to the next page, we have a1 plus, these first two terms will remain because they're already in terms of a1 and a2. And then the next one, we already worked this out in the table on the previous page. And I could keep going in this pattern, and you could see that it's a geometric series. So the first term, we'll leave that alone. Then after that, we can rewrite out the sum. A2 minus A1. We'll have to be careful here because we have this geometric, but we also we're multiplying by a negative, because you could see the role of the negative. Here A1 is negative, so it starts off positive, then negative, positive, negative, and so on. So that's our series. This is a geometric series. R equals negative 1/2. Oops, got a little sloppy there. So we know the formula for geometric series. So this term just comes down, A1. Then you would do the first term of the series by plugging in I equals 0. That's just A2 minus A1. And then you divide by 1 minus R. And then let's just go ahead and clean up this fraction, and we'll end up with A1 over 3 plus 2A2 all divided by 3. And that's our final answer for part B.